This video covers the installation of stick frame roofs over engineered floor systems, according to IRC Section 106.1. Plans must clearly demonstrate code compliance, although this isn't always followed in some regions. The floor system with unknown stick framing above does not just carry floor loads. It may also receive concentrated roof loads through posts, beams, headers, or rafter through framed walls above. With a stick frame roof, if load points are not fully engineered at the time the floor package is designed, it can leave the supplier guessing and either missing loads or over-designing the floor system, costing money. Per the IRC and IBC codes, the person taking on the building design is responsible for specifying the loading. Even when plans look complete, key details like bearing length, load magnitude, and where loads actually land can still be unclear. If the stick framing is not clearly defined on the plans showing material sizes, anticipated bearing locations, and how loads are transferred through the system. Once assumptions enter the design, responsibility gets blurry. And blurry responsibility is exactly what drives structural risk and job site issues. The floor framing, design weather trusses, or conventionally framed needs to be reviewed in context with the roof, not in isolation. How much load is getting transferred each locations must be clearly specified on the plans. Provide a ceiling framing plan with clear sizes, spacing, and supports to ensure load transfer is understood. The roof and rafter plan shows where to place collar ties and kickers, and it gives clear sizes and spacing for rafters, jacks, and hips. This gives everyone a clear idea of expectations and load distribution. Wall bracing is essential but often overlooked in plans. The IRC requires it for proper lateral load transfer in structures. Lateral load transfer holds equal significance to vertical loads. When everyone can work from the same assumptions, that is what keeps risk low. It's a high-risk scenario when teams are no longer working from a defined set of engineered plans that define load and how the load is being transferred. If we are trying to infer where loads go and hoping the structure behaves that way, we are asking for problems. At that point, beams, headers, and bearing walls can be treated as if they solve the problem. Even when the actual transfer path has never been properly checked, someone needs to be responsible for the overall building design. The danger increases again when girder trusses are hidden in the roof cavity. Those members may require web bracing or top chord bracing that gets missed, simplified, or installed incorrectly. Adding a few girder trusses in the roof cavity may get your ceiling joist and rafters to properly span, but does not account for the lateral loads and overall building design. Missing bracing is not a small paperwork issue. It changes how the member performs and structural integrity of the building. When coordination breaks down, the first cost is rarely the last one. A missed load path can trigger redesigns, revised drawings, and a bad reputation. And when responsibility was never clear, disputes follow fast. Who owned the design, who checked the bracing, and who pays for the correction? The best move is to involve sales early and ask for a detailed set of plans that show the stick framing and loads being transferred to the floor system, or push to convert stick frame roofs to truss systems. When the roof system is engineered, the load path is known, and walls, headers, floors, and bracing can be designed correctly. That gives customers a cleaner structure, gives suppliers clearer responsibility, and gives the whole project a better chance of staying on time and on budget. Thanks for watching. Feel free to reach out with any questions. Together we can improve. To design walls, headers, and footings, it's crucial to determine how loads are transferred by the building designer. The plans should specify these loads at their location so the person designing a floor system can properly size the system. Bearing walls might carry a uniform load, while headers and beam ends may have point loads that floors must support. Thanks for watching. Feel free to reach out with any questions. Together we can improve.